All right, well, thank you everyone for jumping on here this morning for our live webinar about utilizing material data with Ansys Granta and Ansys Mechanical. My name is Vinny Lamovic, Ansys sales specialist here at EAC Product Development Solutions, and thank you to everyone for jumping on here. Now, before we get started, I just want to give you a heads up that we will be sending out a recording of this broadcast for anyone who did register. So you will get a copy of this no matter what, whether you hop off, have something come up in the middle, don't worry, you'll be able to catch up on what you missed. You'll be able to submit your questions at any time you want, and we'll get to them at the end. We'll do Q&A throughout. We do not, however, have an exit survey at the end of this, I don't think. Do we, Addie?
I did not add one in, no.
Okay, so no questions for you then at the end. Nice and easy. You can just hop on and hop off as needed. So with that, we can go ahead and begin. So I will get things started a little bit with just a little background of who EAC is and what we do here. Our mission as a company is to try to transform the way that companies design, manufacture, connect to, and service their products. Now, some of you might have worked for us for many years. You've heard us say this at least once or twice, but some of you might be wondering, what do you mean by that? Well, it means that we do everything that we can to try to help companies build better products, and that is connected through our organization and yours, because we don't like to see ourselves as just another value-added software reseller. We prefer to see ourselves as more of a highly trusted business consultant. And if you look at all of the areas where we're capable of providing support, it really does ring true. We're Platinum PTC partners, preferred Ansys partners, and Formlabs partners on the additive manufacturing side as well. On the engineering side, we have a full staff of capable engineers that can assist with product development consulting or any other questions that might arise as you're trying to get new designs out the door. We also have a full implementation staff that is ready and able to come on site or virtually if you prefer as needed to ensure that your PLM launch is nothing short of successful. We are headquartered here in Minneapolis, but we are spread throughout the country to ensure that we will always have someone local that you can count on in a pinch. Now, a little more about the Ansys side of things. Most of you probably think of simulation right away when you hear that word Ansys, and that's exactly what they want to hear. Ansys has taken great pains and put forth a great effort since they were founded in 1970 to do one thing and be the best at it, and that is simulation. This is the only thing that they focus on, and it shows. Their customer support system is unrivaled, with over 450 PhDs on staff in over 70 locations in 40 different countries. I've actually heard firsthand from some of the AEs that we have that they actually enjoy people trying to throw them curveballs with difficult problems because they really do relish in the challenge of trying to tackle something new. So if you have a problem, we would love to help you try to find a solution. Now, if you choose to focus on one thing, you better be the best at it. And Ansys' reputation absolutely backs them up here. They're 3 times bigger than their nearest competitors, and 96 of the top 100 Fortune 500 industrial companies use Ansys. I like to repeat that to kind of let it sink in because it really is an incredible statistic. 96 of the top 100 Fortune 500 industrials are using Ansys software. And a big reason for this is what you see on the bottom half of the screen. They are completely CAD agnostic, so we can work with anyone. Doesn't matter if you're using Creo, SolidWorks, Autodesk, CATIA. The simulation software can plug in with any active CAD platform without any bias whatsoever and work like a charm. Now, I've been using the word simulation a lot, and some of you might be thinking, okay, that's great, all well and good, but what does this have to do with me? I don't know if I can use it. I'm here to tell you that you probably can. I work with companies that use Ansys from the first design sketch all the way up to when their parts go into production. You'd be amazed at what's possible just by having a 10 to 15-minute conversation with one of our applications engineers. Some of the things listed here help give an idea of how we can help as well. We work with autonomous vehicle companies all over the world, help them reduce validation time from 10,000 years down to 2 to 3 years, just with the simulations they can run. And our simulation results are now accepted by the FDA, FCA, and many different ISO certifications that would normally require months to years of testing just to get your first round of parts validated. And our recent partnership with Simutech enables us to really start tackling some of these complex problems and help our customers confront these issues during design, build the best possible parts in the shortest amount of time. So with that, I'm going to hand it over to my counterpart here to take over some of the technical aspects of our webinar today.
All right. So I'm going to start off with an introduction of just Simutech Group and a little bit more about some of the different Ansys technology products. Simutech Group is what we do. We are a trusted group of advisors who help our clients gain insight to improve product efficiency, reliability, and performance using the Ansys engineering simulation software and physical testing. We are the largest Ansys distributor in North America for sales, consulting, training, and support of Ansys finite element analysis, CFD, and electromagnetic simulation tools. We offer mentoring, training, and consulting services, as well as support to all of our Ansys customers. And we also have a standalone Ansys training platform called SimuTrain. We're involved with, we have customers in pretty much every industry out there. We have a long list of it here, and we've done, consulting for other customers in these same industries. So the engineers at Simutech Group have a wide range of different, knowledge and applications for every industry out there. In this demo, we'll be highlighting a little bit more of the mechanical side of the software here. And these are just some of the capabilities of the Ansys Mechanical software. You can do your basic static, transient, and structural analyses, or you can do more complicated things like vibration analysis or seismic, or even work with composites, that kind of thing, all in the same Ansys Mechanical product. Ansys also offers the only true simulation platform that is across multiple physics. So all of the Ansys products are built on top of one interface called Ansys Workbench, and this allows you to share different results from different physics together. So for example, if I have a fluid analysis using the Ansys fluids package, I can feed calculated pressures into a structural analysis in the Ansys Mechanical products and do a structural analysis based off of those results with no setup other than just dragging and dropping those results directly into your structural analysis. So they're the market leader across individual physics, and also they are the only one out there that has this multi-physics integrated approach to simulation. This is just a general overview of all of the Ansys products out there, and you can see they have a wide variety of products for different physics out there. In this one, we're going to be focusing mainly on the structures package, that would be Ansys Mechanical, and as well as the Granta software, which isn't located on here. And that is a material selection tool that allows you to optimize your material selection process. So you're choosing the proper material for your application the first time, rather than doing costly design iterations where you're considering different materials throughout the process. So some of the questions you might be asking yourself when working on with a mechanical application here is will this mechanically fail? Like, is this part going to break during operation? It's how do I find a lower cost material with better properties? We'll be looking at these two questions in this demo, but there are wide varieties of other concerns out there in a mechanical simulation. So now I'm going to hop over to and introduce you to the specific demo we'll be looking at here. And in this one, we're going to be walking through the material selection process of a butterfly valve using the Ansys Granta software. And then we are going to take the material we choose in that software and then validate it in Ansys Mechanical. So the part we'll be looking at here is this butterfly valve, and we want to select an ideal material for the valve body itself. So that would be this circular body right here. We expect this to see the most load and stress during application. So that's the part that we want to consider when selecting a material. So some of the considerations that we need to have when choosing this material is we want it to survive operating conditions without failure. And we also want to minimize the cost of that body. And we also want to be able to make it using a specific manufacturing process. So when I'm setting up my material selection process, we like to break all of our considerations into these three categories here: function, constraints, and objectives. In the function category, we just want to simplify and better understand exactly how this valve is behaving during operation. So we're going to simplify this down as a panel loaded and bending when it's under that pressure load. And we also, our design is stiffness limited. So we don't want that body to deform too much and then cause that valve to leak during operation. You can also consider some of the dimensions that you're working with. For example, we want the diameter of this pipe to be consistent, but we can vary the thickness of the valve body there if needed. So that's kind of the function of that valve body. And now we'll talk a little bit about the constraints. So it's got to have an adequate strength. You don't want any sort of yielding or failure during operation. We also want it to be resistant to fresh and salt water for this application. For instance, that might be what's pressurized in the valve here. It could be controlling water flow. We also want some resistance to adhesive wear. So as this valve is opening and closing, we don't want any sort of rubbing to cause some material to come off and then cause more leaking. And finally, we want to use a casting manufacturing process in order to produce this valve. And then finally, our objectives, like with everything, we want to minimize the cost. So we want to choose a cheap material for this application. And we also want to minimize volume. We don't want that valve body to be too thick. So taking these considerations, I'm going to come into my Ansys Granta Selector tool here. Like I mentioned, this is a material selection tool that allows you to enter all these functions and constraints and choose the optimal material for this application. So to introduce you to the Granta Selector here, we're just going to look at the, excuse me for a moment. We're just going to look at one of the data sets contained within it, the material universe. And what this is it is a complete and comparable data set for all main classes of commercially available materials. So whenever I can browse for a specific material, I can browse for a specific material through the tree here. So, if I'm looking for a aluminum, I can just browse to, a non-ferrous metal, aluminum, then cast or wrought and find whatever I'm looking for. Or I can just search for one with the search bar here. So if I want to look for aluminum 6061, I can just type in 6061 here. And looking in the material universe, I can just pick the specific grade that I want. So here's T6. And just walking you through what's contained in each data sheet. So I mentioned that all of these materials are complete and comparable. There won't be any sort of missing field in these data sheets in the material universe. So you can compare between different materials very effectively. It contains everything from composition data in here to price, It has mechanical properties that you would use for simulation, thermal properties as well. And then it has some non-simulation based properties as well. So like that you might need to consider for a specific, application. Like optical properties, there's also, healthcare properties, whether there's medical grades available. There's also, processing properties and durability stuff, as well as carbon footprint, processing energy, that kind of stuff. All right, so now we're going to go ahead and enter all of our constraints and objectives into the Granta Selector here to find out which materials are best for our butterfly valve here. To do that, I'm going to create a selection process, and I'm choosing from all bulk materials in the material universe. And the first thing I'm going to do is I'm going to apply all of my constraints that we have defined here. So I'm going to, under processing properties here, this is where I can define, that I want this to be able to be, casted. And then under durability here, this is where I define that, resistance to fresh and salt water, as well as adhesive wear down here. And I'm going to hit apply. And you'll see over here on the left, this kind of indicates how many records in the material universe are left. So we started with 3,200 available, materials in the material universe, but after this stage, we only have 100 that meet all these requirements. So now we're gonna wanna be able to visualize all of these materials left to be able to identify, which ones are the best for our application. And to do that, I'm gonna create a chart that plots the performance of each material for our specific application. So here's where I can choose my panel and bending loading with a stiffness limiting constraint. And then on the x-axis, I'm gonna do the same thing, but I want to optimize, sorry about that, optimize the cost instead of the volume on the y-axis here. So you can see I now have a chart that shows all of the materials in the material universe with this volume per unit of stiffness versus cost per unit of stiffness. So since that free dimension is our thickness, the farther down we go, towards the bottom on the y-axis, the thinner that valve can be for the same amount of deformation under loading. And then the same goes for the x-axis, except it's, the cheaper the material, the farther left we go. And all of the grayed out fields are the ones that didn't meet our first stage, the resistance to water, adhesive wear, and can be metal casted. So I'm gonna go ahead and hide those and then just resize the records that I have left. So you can see there's, they're kind of in clusters here. It looks like most of these, red ones here are all different types of bronze or brass. We have a couple of stainless steels charted here, and then some cast iron as well. So it looks like, my potentially best materials here are probably this stainless steel or this high silicon cast iron. It looks like the stainless steel is stiffer per unit of volume, but the cast iron is cheaper per unit of stiffness. So I can compare these two if I want to narrow down which of these two would be better for my application. I can select them and add them to a comparison table here. And this will allow me to compare their data sheets here side by side. So I can view all of their composition, price side by side here. And I'm going to set one of these as a reference, then this will highlight the differences between the material properties here. So if I scroll down, I can see that my cast iron here has a yield strength that is much less than my stainless steel. So for this application, this cast iron likely isn't strong enough. It will yield or fail during loading. So I'm going to use this stainless steel, this cast stainless steel for this application here. If I want to bring this material into my Ansys Mechanical model for validation, It's as simple as opening up its data sheet and hitting export to engineering data. And this will automatically link it directly into my Ansys Mechanical product. So coming to my Ansys Workbench page here, which is that overall, platform for all the physics with the Ansys products, you'll see that my Granta Selector field here with the engineering data is linked into my static structural analysis here. So opening up my project here, which I already have solved, you can see my geometry. And this has that stainless steel already applied to it. I already have everything set up with contacts for how it's gonna, all the different bodies are gonna interact. And a pressure load applied of 1,000 PSI. I can go ahead and take a look at, my predicted stress and deformation on this body here. So you can see that that inner valve body is deforming the most by about, 100th of an inch or so. If I want, I can also view, the stress in this body, and it looks like it's going to be less than my yield strength. The max stress looks like it's about 40 KSI or so. I can plot this as a safety factor in Ansys as well, if I'd like, and you can see, everything's well above a safety factor of 1, so it's likely that this valve will survive operating conditions. And I can even plot stuff like gaps and contacts here. So I have a contact set up with the edge of the valve here in the outer body, and this will tell me how big of a gap I have at that interface to determine whether or not any leaking will occur. So it looks like here it's about it's a pretty small gap, less than 1,000th of an inch. So I can be assured through my simulation here that if I choose the stainless steel, I won't see any sort of leakage during operation for this valve here. And I think that just about concludes my demo. That covers the Ansys Granta software and how you can bring all of that into Ansys Mechanical for validation. I'll go ahead and turn this over to any questions if anybody has any. And using that Ansys Granta Selector, I can be assured that using this material selection process, that I have the cheapest possible material for this application.